Today we're going to talk about arcs and chords, section 11.2. So continuing on with circles, we're going to talk about two of the parts that kind of break up or cut across circles, and that is the arcs and the chords, section 11.2. First thing here, we're going to talk about arcs. Arcs and their measure. A central angle is an angle whose vertex is the center of a circle. So a central angle is an angle whose vertex is in the center of the circle. Well, that makes sense. When you think of central, what do you think of? Center. So a central angle is the angle from the center. Okay, so again, it makes an angle here. That's a central angle. Now, in a central angle, the angle measure is the same as the arc. Okay, so for example here, if the angle measure is 93, that means that arc measure is 93 degrees as well. Now, what's a whole circle going to be? 360. Okay, very good. So the whole circle is 360. So when I'm finding the arcs from the central angle, it's the same thing. An arc is an unbroken part of a circle consisting of 2 points on a circle and all the points on the circle between them. Now, there are a couple different types to label arcs. You can have what's called a major arc. A major arc is whenever you use 3 letters, and a lot of times usually they're bigger than 180. You're going all the way around. For example, ADC is a major arc because I'm going A, then D, then C. I'm going all the way around. If they ever give you just 2 letters, that's what's considered a minor arc, and you go directly the short route, so A to C. That's a minor arc. I don't want to say AC and go all the way around. That'd be a major arc. Anytime you have a major arc, you want to use 3 letters. Okay. If the endpoints of an arc lie on a diameter, the arc is a semicircle and its measure is 180 degrees. Well, that makes sense, right? If I were to kind of split this up right here, well, wouldn't that split that up into 2 semicircles, right? And if the whole circle is 360, well, each one then has to be 180, and that makes sense. Okay, so recognize that. The measure of an arc formed by 2 adjacent arcs is the sum of the measures. Well, that makes sense. You know, let's say AB has a length of, I don't know, like 60. Ooh, that's not 60. No, we'll say 60. And let's say BC has a length of like 20. Well, that means AC is going to have a length of what then? 80, right? Because you're just going to add them up. Okay, so recognize that. All right, so here's what we're going to look at. We're going to look at the arcs and circles. Now, the nice thing about arcs is they really just kind of are very familiar with angles. So we're going to go back to everything we've learned about angles, and now we're just kind of looking at them and represent them in circles. So number 1 says, I want to find the measure of HJ. Okay, I want to find the measure of HJ. Well, the angle on the inside is 63, so that arc measure has to be what do you say, Bryce? 63. Yeah, because it's coming from the central angle, it's going to be the same thing. That's 63. Nice job. Number 2 says, I want to find FGH. So I want to find the arc FGH right there. I want to find that arc right there. Now, what do you notice? I'm missing an angle there, right? But what is FJ? FJ is a diameter. So that means the whole thing here has to be what? 180. So what could I do to find FGH? There's a couple things you could do. What's one of them, Camden? Yeah, I can add up the 2 angles, subtract from 180, and I can find what GH is. I think GH comes out to be, what is it, 52? Yeah. What's another way I could do it? Noah? Yeah. I could take 180 minus 63. Because if I subtract HJ, I get FGH, right? Either way you work it out, what are you going to get for an answer, Noah? 117 degrees. Nice job. Okay. Again, all this is you're looking at angles, adding, subtracting, find some different angles. Number 3, it says measure of angles CDE. Well, what's the arc measure of CD? 90 degrees. Ah, nice job, Martina. Say that one more time, a little bit slower. Vertical angles. Everybody see A, B, and DE? They're across from each other. They're vertical. Vertical angles are always what? The same. So what does CDE have to be then, Tina? 130 degrees. Nice job. And then I have BCD. Well, now I want to find BCD. Oh, wait. I went BC. There you go. I want to go BCD right there. What's one way to find BCD? What do you say, Ryan? I can subtract 40 from 90. Why would I do that? Because then I get BC, right? Yeah. And then what would BC be? BC is? And then I could add them up, right? What's another way I could do it, Nick? For the central angles it is, yes. Troy? Yeah, I can do 180 minus 40. Remember, this right here is a semicircle. That's 180. So I can do 180 minus 40, and I get the same answer. Either way you work it out, you're going to get 140 degrees for that arc. Nice job. Let's try number 5. Measure of arc LMN. So I'm going LMN here. Okay. Well, what's one way to do this? Again, there's multiple ways. One way is, you can start finding the missing angles. One way is, you can always subtract or add. What are you thinking as a way you can do this, Nick Caprio? LMN, yep. Minus what? Yeah, because this is right here is a diameter, so that's 180. So I take 180 minus 105, and what do you get then, Nick? Yeah. You get 75 degrees. Nice job. And then I want to find LNP. Well, okay, here's LNP all the way around. What does PQ have to be? Anybody? Gold up? PQ, how do you know it's 30? Yeah, we have vertical angles there. Nice job. That's 30. So what's a way to find LNP? What would you say? Anybody? Well, what's MP then? Well, MP is 180. What's ML? And you added those two? And you got? 225. Nice job. What's another way? Could you do it with subtraction? Could I do it with subtraction? Couldn't I take 180 minus 1, or not 180, whoops. How much is the whole circle? 360. So couldn't I take 360 minus 135? And would that give me 225 as well? You bet, because I could just subtract the LP going the other way, the minor arc. Okay, same way. Take a couple seconds, try number 7 and 8 here. Using the minor and major arcs and all the central angles, find the missing arc measures. Take a couple seconds to try these. So number 7 here, I want to find QS first. Well, what's the measure of QS going to be? What do you say, Tyler? 125. How'd you find that, sir? Yeah, 180 minus 55. Nice job. Right there. What about number... Oh, sorry, the second half of that. RQT. What is the measure of RQT going to be? Let's go with Peyton. What'd you get? RQT. What'd you say? 100 and what? 227, right? Yeah. Correct. That is 227. And again, one way you can do it is you can find the missing RS here is 78. So if you want to go all the way around, you can take 360 minus 78 minus 55. Or you know that this is 180 right here. And this is 47. And you can add the two and you get 227. A lot of different ways to work it out. Number 8, HG. I want to find HG. Well, what is HG going to be, Mr. Goldknapp?
67.
How'd you find that?
Hold on. I took 180 minus 113 because that's 90.
Nice job, sir. 180 minus 113. Good work. And then what about FEH? What would FEH be? Oh, let's go with K. What do you say? 203. How'd you get that?
I added 180 and 230.
Nice job. Add those up and you get 203. Good work. All right, the next thing we're going to talk about is congruent arcs and chords. Congruent arcs are arcs that have the same measure. Congruent arcs, again, have the same measure. If they have the same measure, that means the angles would be the same. And again, why would the angles be the same? That's like the side postulate there. If you remember, this is congruent triangles. Based on the radiuses would have to be the same as, obviously, right? Because it goes to the circle. And if the chords are the same, that means the angles are the same, which then actually means that the arcs are the same as well. So when you have that, you have all three parts are congruent. Okay? And then the last thing we're going to talk about. In a circle, if a radius or diameter is perpendicular to a chord, then it bisects the chord in its arc. So bisects means it cuts it in what? Half. Nice job. Bisects means cuts it in half. Okay? So what do you notice it makes right here? It makes a what type? Right triangle. Anytime we have a right triangle, what's the special thing we always like to use? Pythagorean theorem. So what do you guess we're probably going to use when we have something like that? Pythagorean theorem, yeah. But before we do that, let's talk about these congruent arcs and chords. So QR and ST are congruent. It says find the measure of QR. Okay. Well, they're congruent. So what does that mean my arcs are? My arcs are congruent. So what am I going to do to solve for x there? I would set them equal. So I'd say 3x plus 22 equals 4x. And then I want to solve for x. X would equal 22. And what do I have to do then, Martina?
You have to plug it in.
You plug it right back in. And you get RQ has a length of what? 88 degrees. Nice job. Number 10. Well, number 10 says that the two angles are congruent. If the angles are congruent, what do you know about the chords? They are. So what are you going to do there? Set them equal to each other. So 2y plus 5 equals y plus 13. And now you want to solve for y. What do you get y to equal, Tyler? 8. Is that my answer?
No.
No, because you have to. Plug it in. GH has a length of what, Bryce? 21. Good work. Take a couple seconds, try these two on your own. Same idea dealing with congruent arcs and chords. Take a couple seconds, try these. So number 11. First off, on number 11, what did you get x to equal, Jack? X equals what? Yeah, x equals 25. Then you plug it back in. PQR is what measure? 125 degrees. Number 12. What do you get y to equal? Y equals what, Trevor? Y equals 7. Then you plug that back in, and WX is 11. Nice job. All right, last thing we're going to talk about is when the radius, or diameter, either one of them, bisects a chord. Well, here's the thing on this. I know the segment to the chord is what here? This is 6, right? What do I know about LM, though? LM is technically a what? It's a radius. What's the length of my radius? 10. So what you don't see here is this distance to LP. What do you suppose that distance to LP is going to be? How do you know it's 10? Because it's also a radius. So it's 10. Well, now that I know that's 10, what do I have right here? A right triangle. Now, on my right triangle, would I add or subtract with Pythagorean theorem? Subtract. Why would I subtract?
Because that's how you do it.
No, because I have the hypotenuse. Nice job. So I would take 10 squared minus 6 squared. 10 squared minus 6 squared is 64. And then my last step is always take the square root. Square root of 64 is 8. Is that my answer, though? No. I want to take it times 2 because that's my whole distance. My whole distance is then 16. Nice job. Let's look at 14 here. EF, same thing here. I know the short segment here is 8, But what is GH? GH is a radius. So the radius from H to E has a distance of what? 17. So I would do 17 squared minus 8 squared. And that would get me 225. And then the square root of 225 is 15. So that means this distance is 15. Double that and I get the whole length, which is then 30. Nice job.
I forgot what 17 was.
The key is, again, you have a right triangle. That is the key to this. Take a couple seconds and try these two. Try numbers 15, 16. All right, let's go through these here. Number 15. What's the radius on number 15 first? The radius is 40. Well, so then I would take 40 squared minus 12 squared. I think you end up with, what is it? 1,456? And you got to take the square root of that, right? And then you end up with, what is it, like 38 point what? And I think I said go to the nearest tenth. So 38.2. But that gives me this length right here. So what do I have to do to find the whole segment? Double it, and I get 76.4 miles. It says round to the nearest tenth. It says round to the nearest tenth. Thanks. Number 16. EG. We want to find the length of EG here. So DE has a length of what? DE has a length of 4.7. So I would do 4.7 squared minus 4 squared. And what do you get when you subtract those squared? You end up getting what?
0.7 squared.
No, you have to square them first and then subtract them, bud.
6.09.
6.1?
Yeah.
I think I take the square root of that.
Yeah.
And what's the square root of that?
2.5.
2.5?
Yeah.
And then you double that, and what's EG come out to be then? About 5 kilometers. Nice job. Again, the key is the right triangles and using Pythagorean theorem and all this.
Mr. Dalen, I think we should get the 3.
Here is your assignment. You know what? I agree with you, sir.
Because Troy has state robotics this weekend, and I'm